Hello, everyone. Welcome to another DOS Audio webinar. Today, we're going to be talking more about East Focus. This is going to be part two. Again, my name is Giovanni Ortiz with DOS Audio of America. I'm the Tech Support Applications Manager for the DOS America headquarters. Why don't we do the quick refresher and let's go over what we did last time. So I'm pretty much starting with a fresh slate. I'm kind of going to go over briefly how all the other things that we did in the last webinar real quick. So last time just so you guys know, we have our options under File Options. This is where we can set up all of our little parameters for working in East Focus. Environment is where you get to change your units from imperial to meter. Extended mode gives you more options in Windows, like your filters or more frequencies under mapping. Under frequency response, this is where we can change the way the frequency response looks, either a bar chart or a line graph. I normally like to use line graph, like I said last time, only because it relates very well to SMART. Colors and mapping. This is where we get to change the way that the colors are represented in East Focus. I normally work in manual, so that way I know what my color scaling is going to be, and it stays locked into the scaling that I choose for it to be in. But if you're working pretty fast and need to start, just getting a quick idea of what's going on with your system, automatic is a great way to start, but definitely when you start working with different clusters, you want to work in manual only so you could stay locked into your scaling for your GB level. Calculation parameters, this is where we get to select the mapping resolution. This is actually a very GPU labor intensive part of East Focus. So if you have a really strong GPU or graphics card, then you can keep it in high and it'll work pretty fast. But for most typical computers, you might want to start working in low or medium, depending on your graphics card. And then once you're ready to get a really good view of your coloration, then switch it to high or highest and let it render out so you can have a nice clear picture of your frequency response. Down here, we also have complex sum and power sum, which is important for today's lesson. Let's go through it. Power sum and complex sum. Oh, another page that I didn't put in English. Well, anyways, the difference between complex sum and power sum is pretty much power sum allows us to see everything in the same power radiating. So if I put two subs in, let's do that. I put two subs together. Let's do our UX218 in standard, so I can get one sub. Okay. I'm going to change this to automatic. I'm going to put a view real quick. So this will be one sub together by itself. If I copy and paste this, now we're able to see the boxes working in complex sum. So what does this actually mean? This means that I can see the interactions between the two subs that are placed far apart of each other. If I go into the options and in calculation parameters, I switch just to power sum, I will only get the radiating sum of the boxes. You won't really see the cancellations or where it's summing up a lot more. So definitely for the sub range, it's very important to keep working in complex sum at about 125. Because after 125 and below, it's pretty much where we're working with our sub percentages. So yeah. As you see, once I go back, now we can see that we have cancellations in certain places and a nice power rally for our summation. Plus, we're throwing sub-frequencies off to the corners, as you would in any LR situation. Uh, Lastly, almost, grip and snap is pretty much just so how we can work the grid. I always leave it in full grid. That way, when I'm dropping something in, it'll lock into the grid points and be easier to manipulate. And then under view, it's important to select rulers on side view and top view only so that way we can see exactly what the measurements are laid out in a quick view. The rest of the measurements we'll be able to do by typing it in or using a little tool that we have that is shift. Once you hold shift, our cursor turns into a crosshair, and we'll be able to drag and hold, and we'll be able to see a measuring tool that we get of and I'll show you either in units of distance plus time. So as you see, I'm right now measuring 157 feet, and it's roughly 140 milliseconds of distance. Cool little tool that we have there. We also have all of our windows. Again, I'm doing a quick overview of what we did in the first one. The first webinar goes a little bit more in depth of every window and button and stuff like that. But here's a quick update on the window. So project properties is where we get to title, notate all of our projects, plus be able to work with the weather. We'll be able to use temperature, humidity, and air pressure. If you look at the first webinar, this goes a little bit more in depth, but this is pretty much if you use this properly, and you'll get a more accurate reading of what your high frequencies are going to do in that type of environment. Project settings is where we're going to have our ear heights standards for sitting and standing, and you can also have a customization one. Default limits for heights. I briefly went over that in the first webinar as well. In object properties in the bottom tab, this is pretty much where we get to edit any device or any zone, area, or so on, or microphone that we place into the top view. Down here, we'll have a bunch of windows on our side view. We'll have filter, global filter, distribution, time response, frequency response, and level. Now, level, time, and frequency, things need to be placed into here in order to get any usage out of these windows. Distribution graph is, we'll get more of an update as you start putting more objects into your view. And then let's talk really quick about global filter and regular filter. Global filter, we can think of global filter as our input EQ of our process, because our output has individual EQs to tune or attenuate any of our outputs, our left to right PA, our subwoofer channel, our front fills, out fills, so on and so forth. So, but the global filter is going to be your input to the processor. So if I attenuate in the global filter, I will attenuate all of our PA, all of it, from our front, from our main PA down to our delays, subs, and everything. So if I'm working with a specific tower, a cluster of speakers or a sub, and I select that, let's do this AERO 2040. If I drop this bad boy in, I selected it. Gotta give it a second to load. I just placed this guy here. This global filter will attenuate this one. But this filter, once I have this selected, would be attenuating only that cluster of speakers. So that is going to be your output EQ. So one more time, our global filter would pretty much be our input channel for our processor, and then the filter tab would be an output of the cluster that you have selected. So now that if I have this cluster selected, I go to filter, press the little double arrows on the side, and I'll be able to do any EQ point changes that I need to if I wanted to test some things out. And then invert, polarity, phase flip. This is your output channel. This would be your input to the processor. Just a quick little overview on that. In top view, we have our buttons that we normally control everything with: zoom in, zoom through, zoom out, input picture, all of our audience areas, sound sources, selection planes, and our receivers. Our selection plane allows us to get a different view of our PA. So right now this PA is low to the ground. So let me just do this real quick. Put this at about 660, not 760, 660. So as you can see, that once I select the selection plane, I'll be able to get a front view of the system. Cool. So now that we've done that, I'm going to delete these and I'm going to add an image into here to start our little project. So I'm going to rebuild the session that I did last time so we can all kind of get another glimpse of how to add our images, how to add our audience areas, how to manipulate stuff, and then we'll continue into the sub portion of today's webinar. So first, what we did was go to Layout Picture. Under Layout Picture, we are going to find the image that we're using last time. That if you go to Handouts, you should be able to see it in that under Handouts as Figure 1. Figura 1. Here. Oh, not this one. Okay. Once I've loaded the image in, I now have to tell the image what size it actually is. The program does not know what the dimensions of the images are. So this is a drawing that a friend of mine did on AutoCAD, and I already know that the center portion is going to be 80 meters long, which 80 meters in feet. Anyway, so I'm going to actually change the way I'm looking at the environment from units, from imperial to meters, and we'll be working in metric because I know that this is metric. A cool thing about this project, this application as well, is once I actually give this 80 meters, I can go back in and change it to feet, and it will change the dimension, the units accordingly. So the way I normally use this A and B points right now is I always try to find the center of my stage, put the A point there. The reason why is that I'm going to try to make the center of that stage be my cardinal points X of 0 and Y of 0. B is always going to be at the end of the furthest distance. And now if we look at the bottom portion on the bottom right-hand corner, we'll see point A and point B, which relates to these two points that I put here. I want to make my cardinal points x and y 0. So if you notice that point A is x and y, I'll put it x at 0, y at 0, making my cardinal points x, y of 0. I pressed enter, but if you notice, if I press enter, it closes the entire window. So try to hold off from pressing enter till you're done inputting all your information. Point B is going to be the distance from A to B now. So I'm going to put 80 meters. And now that I've actually put all my information in, I'll press enter. And now my image has scaled to that distance. I'm going to go back and change this now to imperial so we could see what it is in feet. Let's see, use it for us to work it. So now we're in feet, and if we do the shift click, which you would measure, and that's roughly about 262 feet. So that's a cool little tool that we have there that we can. Now that we have our image in, we have to decide where is our audience area. What are we trying to cover? And now that this is to scale, all I really have to do is select one of my audience areas and just draw it out real quick. I'll be able to move it to the front and center point. But an easier way to move it to front and center is if we go to our object properties, we'll be able to put front and center again. So 0 and 0. We put 0 and 0 because I made the origin point of the center of the stage right in front, 0, 0. I want to make sure my audience area matches right up to that point. Once I do that, I can extend my width. Where I need it. And go all the way down to the bottom. So normally when I do that, I always go back into my object properties and kind of even out my dimensions. This one's going to be 264 in depth and 177. Now I have a nice even point. And I'll even out left and right. Excellent. So once I've put the dimension of my area, I want to make sure that I select what kind of environment I am. And normally in this scenario, this is a big indoor arena, and there's different scalings. We'll have a floor area, we'll have a balcony 1 and a balcony 2. So with this audience area, I should be able to add a couple areas into it, dividing up the audience zone into different areas. And as you can see in the side view, I'll be able to get some levels. So let's go off to say that the first floor is only, let's do that. The bottom floor only goes up to about 110 feet or so. So 110 feet. Length. The second floor, actually do 150. I'll meet in the middle. There we go. Second floor, I'll start it at 125. And normally we will have all our tools readily available, and we'll be measuring this on the spot. So I would measure what the ground floor is to the first chair in the balcony, and then see what for the first chair to the back of that, the back of the first balcony would be. Which let's make it only 75 feet. Normally in balconies we'll have an angle because there'll be seated areas and they'll have a view. So with an inclinometer we'll go and measure the angle of our balcony, and in this case I'm going to give it a 10 degree a 10 degree of angle inclination. I'm going to add a third area real quick, and I'll start it at 200 and end it at the 264 at the end. And I'll also give it an angle of let's say 10 as well. So if you see, we can make all these different angles so we can try to cover them as we need to. We can build an entire way of using this. Once we've designed our audience area, the next thing that we're going to be able to do is now select our PA. If we look at our image right now, you can see two clusters of where we could actually two towers of where we could put our cluster on the either side of the stage. So why don't we get an AERO 20 rig, an AERO 40 rig. This is a very wide spot, so we'll be able to do that. Going to select an AERO 20, which is using our sound source tool. Sound sources added into the little spot right there. Let it load. Not this one. There. eFocus tends to be a little picky with all of these GLLs. Just give it a second to load. Don't give it too much work to do because you can get it stuck at some point. So I do recommend, when you open up these GLLs, just let it load, give it a second. It definitely helps to have the mapping off while you're doing it to load in the file. Okay, so we have all of this distance, 270 feet that we're trying to cover. I'm going to say we are going to use 12 boxes aside, and we're only going to aim it at the first two levels, because the third level, we're going to give it a delay stack. So I'll bring it back up. Let's see. We'll say that the height of the towers, the max height is 35 feet. Now we don't always have to go to the max height of 35 feet, but it is important to know what our heights are, because once we put a height in here, if you notice these GLLs don't account for the rest of the rigging tools that we're using, our span sets, motors, chain. It doesn't calculate for that. It's only calculated to the top of the bumper. So an example, if we only have 35 feet of height, we are already going to lose at least 2 to 3 feet of that height due to span set, motor, and chain. So if I measure that I have from the ground to the rigging point 35 feet, I might start looking at this PA at roughly 32 feet. Yes, that is going to be probably my max height. I might not stay there, but it's a good starting point for the height that you have, plus the height that we're trying to get for the audience areas. Once we've selected the amount of boxes that we have, put the proper height. I normally like to round off these numbers just to make sure everything's nice and even. So that when I copy and paste it to the other side, it's pretty much exactly where I want it. So I always work completely on the left side first, or the right side, whichever side you want to start on first. I do one side entirely, and then I'll copy and paste it to the other side to save myself some time. If you're doing a project for a quick pinch, you get to a location and you need to throw a pinch system now, doing just one side is sufficient enough, because you're going to do the same to the other side. Now, if you have outfills and other front fills to account for, yeah, you're going to have to take the time and do all of those calculations as well. So let's continue here. It's always important to label your boxes. This is going to be our AERO 40 right. To name the right. Next, once we labeled, we selected those boxes, put it in its proper position, our coordinates, we will go to filter settings next. It's very important to go to filter settings, because this is where we're going to to our rate compensation. If you go back to our first ease focus, we talk about number of units and how it's crucial to add this into your system every time you fly it, only because you're going to be missing highs if you don't do so. Once you have a bunch of boxes summing together, it sums up a bunch in your lows and mids, thus not canceling your highs, but severely overpowering your highs. So what these number of units do is that it brings back the highs to, well, brings back the amount of highs it needed to make that entire array sound exactly like one box. If you notice here in filter settings, I selected 12 boxes, but I have some that are long throw, some that, and all of them are at 8 units, and some that are one stack unit. If you go to edit and line array presets, the AERO 40s and AERO 20s, we have presets already made for sizing of PA. So if I wanted to do a 12 unit hang, I can select 12 units. It will give me 12 boxes, plus it will change everything to 12 units in your filter settings. But it's very important to still go ahead and look at your throws. I always start with my throws at mid, and then go back into it when I need to make changes in the mapping. So being that we're just starting with the leaf settings with 12 units, mid throw, perfect. We can go back to rigging, and now we're ready for auto split. Auto split, once again, is our algorithm. Ease Focus's algorithm to splay out the amount of boxes towards your audience area. So I'm going to select auto split. I'm going to select my top box, first box, last box, and then I'm going to use conventional. I go over all this portion in Ease Focus 1. So if you need to refresh on that, just go back to the first webinar. I'm going to select only areas 1 and 2 for the simple reason that I want these 12 boxes to only cover those 2 levels. Let's start. Just going to do its calculations. And there we go. This doesn't have to be the end all be all results. Once we turn on our mapping, we can go in and start changing our angles as we need to. Just by grabbing some of the one of the boxes, say I need this to come down a little bit. Most likely than not, I'm going to want this one to come down a bit. Spread that a bit. And I'll bring this one up a bit just to recover that bottom area. One thing that's very important is the pinpoint and delta. Pinpoint is where you're going to put the pinpoint for your rigging bar to fly to your motor. But if we have a delta in here, that means it's telling you the amount of degrees of pullback we need for the PA, so that way the PA at 32 feet up in the air with 12 boxes at pinpoint 9, I need to pull back half a degree in order to get to this end. So a trick that I do to kind of make sure that the angles that I have set, the pinpoint that I have, and the imagery that I'm looking at all stays in the relativity of how gravity works, I want to remove that delta. So if you press pinpoint, it'll turn into NA, so we can use a 2-point hang, but then I can press pinpoint again and it removes the delta. But if you notice, I have now raised my PA angles are now pointing a little bit higher, half a degree higher. All I have to do now is pretty much lower my PA a bit. Let's do the 31 feet. Let's go to 30 feet till I get that top box right at that back row. And if you notice, all I did was balance the system to work as if it was hanging from gravity. Now I'm fully confident that if I fly these 12 boxes at pinpoint 9 with all these angles at 30 feet, it would get this coverage amongst my audience area. I don't have to worry about any pullback or push forward or pushing the PA forward to get to the exact angle I need. I've taken away that delta, the extra thing that we need to do. Now that I've done this entire side, I can copy it, paste it. Again, give it a second, let it load. Ease focus tends to be a little slow. Mhm. So I did forget to do one thing that I wanted to show you guys that I talked about earlier, which was our filters. If you notice, we didn't have the high pass filter in the AERO 40's filter settings here, right? Normally in our AERO 40's inside of the boxes, we can set it, but in this GLL, we don't have it there because we're going to go select filter, press the little up and down arrow button, and we're going to create our own high pass here. We're going to put high pass at 80 and a Butterworth 24. Now we can't select Blinker Drive Butterworth, but we just do the octave, the amount of cutoff that you would want. So I'm going to use Butterworth, negative 24 octave at 80 hertz. And if you look at the bottom, it's already bypassed. And you can tell because the EQs are flat. If I go bypass, now it puts in that curve. Now I have put the crossover that I wanted to, or at least a high pass for the 40s, which I'm going to use later, so that way I can timeline the subs in real life to the 40s. Now, seeing that I already copied and pasted, a cool feature that Ease Focus also has is to, if you have like PAs, I can select the one that I make my changes on, which is the right one, and I made all of these changes on it. I can literally go copy setup to other line array. Copy setup to other line array. Now, it's kind of confusing because I didn't label the other one. Another thing about Ease Focus is that we always have to label. If we don't label, things get duplicated, and we don't know which one is which. It's easy to get lost. So I'm going to go back. I'm going to relabel the left one that I pasted. I'm also going to make sure that my points are the same. So this one, my position is the same. The first one is -6 on the X and 45 on the Y. Now I'm actually going to do something. I'm going to put the Y opposite. I'm going to do -45 because I need it to be on the opposite side of the stage. -45. And now I'll do -6 on the X. Now we're completely symmetrical on the stage. Lastly, go back to the copy and paste of what I was doing for the filter. You notice I'm switching back and forth, and the filter is changing because one has the filter on it and the other it does not. Because this filter tab is our output of our processor. So I've only done it to one side. I'm going to copy setup to other line array. I'm going to select my AERO 40 main PA left, press OK or enter, and now both sides should have the filter sets. There it is. So now we have a completely symmetrical design in our Ease Focus. If we turn on our mapping, now we can see the coverage of everything. There we go. And with this information, we can now tell that we're going to need some front fills right here. Even without the mapping, we'll be able to see that our 90 degrees is hitting about 15 feet away from the barricades. So we have a little gap there. So I might just put, 2 front fills pretty close to the center and just to cover that area. So why don't we get another speaker? We'll do the AERO 20s. Do AERO 20 ground stack with ground stack of 2. This focus is going to be tested. There we go. Let it load. Remember, be patient with these focus. If you're patient with these focus will treat you well. So this one is going to be our front fill. Let's zoom in a little bit. Let's see where we want to be. So I'm thinking there. So we have 10 on Y and 13 on X. I'm going to change my setup from arrow 40 flown to arrow 20 stacked. If you notice, AX is flown, AXS is stacked. I'm going to do 20 front fill left. Actually, right. I'm going to put a box count of 2. And I'm going to go to my filter settings and make sure that they're in a stack of 2. And because they're front fills, they'll probably be really close to the audience, so I'll leave them as short fill, just so I don't chop their heads off with high frequencies so close. Once I do that, now I can just copy and paste. Remember, do everything on one side first and then copy and paste it to the other. But actually, I forgot to do one more thing. Let's put our high pass filter on this one as well. I'm going to put 80. We're going to select the unit again, go to filter, select the 2 buttons, the button on the right bottom corner, type in 80 on the high pass and 24 on the cut and on the slope, and then we will turn off the bypass. Now I can copy and paste and put it at the same coordinates, but opposite. Copy and paste, let it load. Go in here, I did X of 13, and now because I'm on the opposite side of the stage, I'll do -10. I always like to input my information versus just dragging and dropping. I get more accurate results, and I put things exactly where I want to be. Plus, I get to stay more symmetrical. So I recommend always working in typing in your values versus just placing them. I place them to get a ballpark idea, like you've seen me do already. But then I go in and I correct my cardinal points. Just makes it easier to digest and share. Now that we have front fills, we can turn on our mapping one more time. See that we've added more pressure there. Turn these off, see what I'm missing. See, it became a little bit more yellow. Turn these back on. Oh, there's one thing I didn't do. I put this all the way up in the air. If you notice, I left them at 30 feet high because I'm not looking at my side view. So I got front fills up in the air. So let's say this stage is roughly 4 feet off the ground. We'll call it 4 feet off the ground. Go to one of my front fills, put Z, which is our height, at 4 feet, press enter, and then I can copy setup to other line array. If you notice, our arrow 40s and arrow 20s are the same GLL. So this is why it's very important to label your stuff. I'm going to select arrow 20 and copy to just the other front fill. Boom. Now we're there. Now those are standing right in front of right on the stage. If you notice, our scaling has changed again, our coloration, due to this being automatic. If I kept this in 114 to 90, now I get a more static imagery. I cannot focus on what I'm on the entire range. Now I definitely know that I don't have enough frequencies in the third floor, but I have a nice coverage on the second and first floor. But if you notice in the back, it looks like we might need a couple highs. Another way that we're going to figure that out is by putting our microphones in, which I tend to select one side. So front, blue for near, green for just about center, and red for far. I put a front one for the balcony and a rear one for the balcony as well. Let's do that, and we'll go to frequency response. Now we can see the curves of our PA. If you notice, it looks like we don't have a lot of low end. One, we don't have subs yet. Two, we are in A weighted. Difference between A weighted and Z weighted is all frequencies at the same level, pretty much like pink noise, and then A weighted is comparable to human hearing. So we're visually looking the way that we are going to perceive it. I believe this is pretty important to understand, because normally if you're always working in Z weighted, you might not add enough subs because you might think you have too much sub. If we add to A weighted, now we can work on our PAs in A and know that our tops are fine, and when we add our subs, we can have a balanced out system. Cool. So now that we've done pretty much that portion of our refresher on that, which is putting our main PA, putting our front fills, covering the angles, now let's get into the fun part, the new part, subs. There are two ways to do these subs. If we go to sound sources, there's standard configuration and subwoofer array. Standard configuration is so we can use one sub at a time, and sub array is exactly that. We can get a line of subs and work with a bunch of subs as one GLL device. In this case, we are going to go with subwoofer array, and I'm going to add UX 18. Now it's there, I'm going to place it dead center right in front of stage. And if we need to make sure that it is exactly 0, 0, we can go here and put 0, and it's not 0, 0, it's all the way up in front of the stage. So I will put it at 17, which will be directly in front of that half circle. So what do we see here? This object property window is now completely different. But it has a couple of things that are similar. Our configurations are still pretty much the same. Our positioning and orientation are exactly the same. And we have a new box on the bottom that says box location and delays. This is a cool feature that we're going to have, because this is how we're going to create our virtual arcs. This is how we're going to be able to steer our subs so we can maximize our coverage of our subs, not just by adding subs, but by spacing them, adding delay on each individual cluster, and see how all that works. In the meantime, I'm going to mute all my PA except for my subs. And then I'm going to change my my mapping type from A weighted to Z weighted. Reason why? Because Z weighted will show us our real sub coverage and real sub amplitude. Now, because we put our crossovers at 80 Hertz for our main PA and front fills, I'm going to start off by putting our low pass filter at 80 as well. That's just how, mainly because that's how our boxes work best together. Once you put a crossover on the top, you kind of want to copy it on the same one at the bottom, and then time align it in real in real life, not in East Focus, because East Focus can be a little confusing to so now that we've placed that sub there, they're all bunched up together. I'm going to get my selection plane and draw a line down the center. The reason why I want to do that is so I can view it from the front. Now I can see my whole PA on the side view, which is really nice. And for this project, I'm going to lock the window here so that stays exactly like that. So now that we're only looking at the subs, and I am going to put it on automatic scale. So really want to do perfect. So we only have 12 subs. Actually, no, we have how many subs? We have 5 subs. So going into this, we can now do lines of subs because we selected a subwoofer array. In box count will tell us the length of box, or the amount of boxes that we want in one line. So why don't we go and select a line of 12 subs? If you look at your drawing, once it loads, now we have a line of 12 subs. There it is. Right in the center. Another thing that we got now is that we can stack subs up to 3. So if we were doing a really big concert and we needed to have 12 triple stacks of 18, we can definitely select that and place that all right in the center. You'll see that all these box counts will start rising, plus they're all bunched together, and they'll start giving you the positioning of each box and delays if it's necessary. So few projects. But in this case, I'm actually going to use only one row to demonstrate one line. If I needed to do cardioing, because we have the option to do cardioing, and I want to do a line of cardio, all I would have to do is we can't do it in the same GLL as one giant block, but I can still recreate it by copying this exact GLL. Understanding what my height of the sub is, which is going to be about 1.5 feet. I'm going to paste this sub directly on top of the subs that I already have there. Make sure that it falls directly on top of each other. And I'm going to grab, first I'm going to put it 1.5 feet high. So I can see that it's directly on top of each other. Looks like it's going to be 7. Much better. And then I'm going to grab the line and turn it 180 degrees. An easier way to do that as well is by typing in the values right there. Now we want to make sure that this is directly on top of each other, which I had put 17 on X and 0. Lastly, we now have to activate the cardio system. Just select that sub, and I'm going to go down to filter configuration, filter settings, and the input configuration, put cardioid unit of 2, and I'm only putting it on the top box. I also have to put the as well. And now, as you can see, we've taken out a lot of energy back here and left it all in the front. Moving forward. So let's focus now Now that you've seen how we can do cardioid, just with a line of subs, let's focus on how to maximize our coverage. So now that I finished that exercise, I'm going to delete the top one just so we can have one GLL that we're working with. And I'm going to put it in a double stack of 2, each one, to have a total of 24 subs. Let it load. Now, if you notice, just out of the box, putting in, it's already asking me to put delays into each cluster of subs. And if you notice as well, there's a height difference between certain subs and a placement. This is going from left to right, and it's bottom box, top box. So 1, 2, 3, 4, 5, 6, so on and so forth. And then you can see that it has delay that it wants you to insert on each cluster of sub. The reason why is so that way we can create our arcs. Let's see what this sub looks like when we are in all 0, really quick. The way we're going to do that is by looking at our coverage angle. We're going to grab the coverage angle and we're going to press 0 and enter. Now, obviously it doesn't stay at 0 because if we have a coverage angle of 0, then we're not covering anything. So the max coverage that this array now does, the lowest that it can go when everything is 0, is 32 degrees of coverage. And if you notice in the drawing, we are now creating a cannon. So we are going to now grab these microphones and we're going to see how it all changes in our frequency response. I'm going to set one dead center on axis to the subs, and then make sure that I know what distance I have placed it at. So it looks like 41 feet or so. I'm not going to put the other mics further away, roughly around the same distance of the first mic. What do I mean by same distance? I'm going to be slowly getting off course, but I'm going to make sure that I stay at around 40 feet away. That way I get a better understanding of what my coverage is. Now I'm going to turn my subs, my mapping back on. I'm going to go to frequency response, and there are the differences in each one. 40 feet. If you notice, we'll take off this one real quick. Piece 3. Blue we have at 125 dB, green we have at roughly 115, and red we have 111, 109. That's roughly at 63 hertz. Let's go back to ourselves and let's start widening our coverage and see what happens. I'm gonna go to 40 degrees of coverage. The lines got a lot closer to each other. I was able to widen my throw. I'm going to do it again. I'm going to go 50. If you notice, the more that I open the coverage, the less throw I have with my subs. This is you'll have to kind of play with this till you get the coverage that you need, or the coverage that you're looking for. Maybe this isn't the best distance between the subs. Maybe I still need to get a wider coverage while still getting further back. If that's the case, why don't we check the spacing of our subs? Spacing of our subs. This word spacing does not, it is the spacing between each sub, but it's technically the spacing between center of sub to center of sub. What do I mean by center of sub? I'm talking the literal physical center of the sub is the distance, is the spacing that we're going to put here. So if I wanted to have 5 feet apart, all the subs 5 feet apart, it's not 5 feet apart from sub to sub, from the edge of the sub to the edge of the sub, is 5 feet apart from center to center. Pretty much the center of the cone, so the center of the box to the center of the box. So if I was go to measure this distance to here, that should be roughly 5 feet. Now with that, we got a wider coverage of our PA. The more we spread, the less we're still going to throw back. But we can add, if we go back to 0, you're going to see that our coverage is wider, but it's still a can. These are all different ways that we can utilize to play with our arcs of our subs. I'm gonna keep it at, let's do 60 degrees coverage, and let's talk about these delays. Where would I put these delays? If we're just using any type of sub whatsoever, not every sub has DSP built into itself. So we would need multiple DSPs, multiple outputs with delays on each output, so we can create this arc. So let's grab a 4080 to fit, and we'll have 1, 2, 3, 4, 5, 6, 7, 11, 12 subs here. 1, 2, 6, yeah, we have 24 subs here. How are we going to get the outputs to these subs and to get the proper delay? Well, if you notice in the East Focus, everything's bunched up by 2s, but everything you do to one side is also the same thing you do to the other side. It stays very, very symmetrical. That being said, the 2 clusters in the center would be one output. The next 2 clusters would be another output, so on, so forth. That way, whenever I change delay here, it does the exact same thing to the other cluster. That way you stay symmetrical and even across the entire coverage or your setup. Now, for our purpose, for DOS.NET and AERO 20s and AERO 40s, we have DSPs built into every box. Once we connect into DOS.NET with our processor and all of our units in Cat6, and we have control of every single subwoofer, we can now build this digital groups of these in DOS.NET to organize ourselves and then link the delay channels between this. So now I only have to send one audio chain to all these subs, one audio line. But then in each box, through the DSP that's built into it, I can add the delay to each box. So I can link the two outer ones on either side. So that'll be 4 boxes, DSP 1 right here, out 1. I can link all 4 boxes together for their DSP, their delay unit, and put the 8 milliseconds that it's asking for. And I can build my delay there while still saving the output channel delay to time align it to my main PA. So delays that go inside of the subs are only to arc your subs. Delay coming out of, in our case, for our speakers. Delays coming out of our output channel is going to be to time align the sub channel to our main PA. But then the delays that are in each unit of our subs will be linked together with its appropriate counterpart and then delayed there to create our virtual arcs. Kind of like you see here. The more that we try to open it, the wider it gets, the less delay we have. What's cool with East Focus as well is that if you know how to do Endfire or any of these other complex or sub-arrays or configurations, you can do designs here. You can use this as your virtual playground to do so before you get into a live scenario. In East Focus, I don't generally time align my subs to my tops only because this is a virtual world. I'm not going to use that time delay in a real world scenario, because I might be the stage might be an extra 5 feet for some reason, or there's gonna be real world changes that's gonna happen, and you're gonna have to adapt to it. So I don't focus on time aligning inside of each focus. I just want to make sure that my coverage is exceptional, that my frequency ranges are the way I want it to be, that my distribution graph, that I have an ample coverage, an average of an SPL reading amongst my entire audience area. That's the main use of East Focus, to get your ideas down on paper before you get to your location. So that way, when you get to your location, your setting up and everything else becomes a lot easier because you've tackled most of the issues that you're going to run into. So that's a little sub course right there with our with East Focus. If you guys have any questions, please let me know. There's my email. Once again, my name is Giovanni Ortiz. I'm the DOS Audio Application and Tech Support Manager for DOS Audio of America. And I'm here to help you guys out with anything else that you guys would need.